Hello, my name is Kandha Sankarapandian, and I'm the head of WWSO Prototyping team. Prototyping is an AWS investment into our customers to build working proofs of concepts and prototypes for specific business challenges. The prototypes are typically built in a 6 to 8 week period. We build for the customers. We also sometimes co-develop with the customers. For that later part, we've often heard from our customers that they would like to meet in a common location. This could be at the customer's own site. It could also be in an AWS office. Typically in the past, this happens to be in like a boring conference room. For prototypes that involve hardware components, especially our IoT and edge prototypes, we've often had this need to have a lab where we can come together as a team and build these prototypes that demonstrates what we like to call as art of the possible. And I want to welcome you to one such lab right here in Santa Clara. You just saw the automotive demonstrator and the Outpost labs. We envisioned this lab to be a space where we can bring in both customer and partner build solutions and prototypes that have led to these demonstrators to be showcased, and also have the space where we can invite our customers and partners to co-develop with us. So starting with, I want to highlight the Makerspace that we have here, especially for prototypes that require these specific tools to build those prototypes. Let me do a quick walk through of what equipment we have here. So over here, we have equipment that will allow you to design your printed circuit boards. So you're able to use the microscope, including a USB one, to visualize as you're designing the prototype PCB board. Once you have that design completed, we'll actually move over to this area here, where we can use this PCB printer to design and print the board that you just designed. So we kind of have these ready to be used in a prototype. So from here, I'm going to go over to our testing station. And in the testing station, we have an oscilloscope, which we will use to test and validate that our PCB board is working as expected, measuring our input-output voltages, and any peripherals that may be attached to it and would be driven by it can all be validated using this portion of our workshop. From here on, we're going to actually move on to a 3D printer that we'll be using for some light manufacturing. Over here, we have a 3D printer that we can use for manufacturing those enclosures, let's say, for the PCBs that we just printed. You can also do other kinds of light manufacturing right here for demonstrators that we'll be featuring very soon. Things like mini windmills that we can then inspect using our drones that is just set up right there and is ready to go. So the idea behind these labs is to co-develop with our customers and build these prototypes, which can then eventually move to production with recommendations on how you can take a prototype into production. Those are things that we deliver as part of our prototype. So here's an example of a prototype that we converted into a demonstrator, because the technology and the solution that we built is applicable to multiple customers. Let me start with a quick demo of what you are seeing here. So this is a smart manufacturing demo where we are able to use Lookout for Vision, Amazon Lookout for Vision, to detect when there is a defective product in your manufacturing line and instruct Universal Robots UR5E cobot to pick out those defective products out of your manufacturing line. So this would eliminate humans in the loop to do those kind of visual inspections. And this is particularly useful for cases where either the task is very repetitive and you want to continue to maintain the really high throughput that you want in the manufacturing scenario, or it may be even situations where these are like very far out, remote gas pipelines where human inspection, human visual inspection will be cost prohibitive. So we can apply the same kind of idea and use case to multiple use cases. To start things off, let me show you the positive case. So we are demonstrating this by making use of these little Rubik's Cubes. The machine learning model that's going to be running on the edge that has been trained using Lookout for Vision is able to detect when a Rubik's Cube has not been solved. So these are trained as cubes that are defective or products that are defective to be removed from the production line. So the cubes that have been solved are detected as good products and are allowed to continue down the conveyor belt. So let's start with a good scenario here. So I'm going to drop one of these into the production line, and no action was taken by our robot. But now, if I were to drop one of these defective products, what's going to happen is an inference that ran on the edge detected that that particular cube is actually a defective product, instructed the robot to descend down, grab the product out of the production line, and drop it out of the way. So this way, you're able to do inspection, visual inspection of defects in your production line and remove them without any human intervention. We were able to implement this solution, highlighting the architecture behind this demonstrator. Starting with, we have these images that were collected in order to train the Lookout for Vision model. Once the model has been trained, we actually deploy this into an edge device, which is where the actual inferences are going to be happening. Now, in the edge device, we actually run a client that is able to talk to AWS through IoT Core and IoT Greengrass, utilizing an MQTT connection, and is able to tell and inform metrics around whenever the camera detects defective products, what was the confidence level in detecting those defective products, and use that metric to start building some analysis on, let's say, your OEE metric. All of that is, again, made possible through that communication channel that we established through IoT Core. And the data and the demo includes a dashboard where you'll be able to see a preview of the detected cubes, because the camera is actually continuously looking at the conveyor belt, and it is able to detect like when it is when something is a cube, and then do the Lookout for Vision model to detect if that needs to be removed from the production line. So here we have a demo of a prototype that we built with a customer. The customer infrared cameras came to us with a challenge. The cost per camera was upwards of $300 per camera per month as architected. And they were also seeing latencies that exceeded 6 to 9 seconds, which did not really bode well for their real-time monitoring use cases. Now, infrared cameras actually manufacture these thermal imaging cameras where, as you can see in this display, every pixel in the image that you're seeing here represents a temperature reading. So these are all false colors that are shown for human visualization, but every pixel can be used for determining like what is the actual accurate temperature on the field of vision that you're looking at. Now, what infrared cameras was able to do is typically these infrared and thermal imaging cameras were several, even reaching hundreds of thousands of dollars, where the applications were limited to situations that require or can benefit from such high investment, and occasional monitoring where a human typically carries these large infrared thermal imaging cameras, goes around inspecting and using that thermal imaging for applications. ICI, or infrared cameras, were able to shrink down the size of these things to something that I'm able to hold on my hands, and also reduce the cost price point, where now they're able to, utilizing AWS as their cloud provider, solve use cases that requires continuous monitoring using these thermal imaging cameras. One such application that we have on demo here at our lab is a use case involving a distribution facility. Imagine you're an online retailer and you have large distribution facilities with many miles of conveyor belts. You do not want these conveyor belts to break anytime. causing unplanned downtime to your distribution logistics. What the thermal imaging solution is able to afford is, let's say if a belt is tightened incorrectly, it will cause uneven friction on one side of the belt compared to the other. This would be not visible to your naked eye or to vision-based system, whereas thermal imaging is going to pick up that additional friction that is happening. So when you go look at that image in the AWS application that is built by ICI, you will start seeing those patterns where the one side of the conveyor belt is showing hotter than the other side. This would be a good indication for you to do some preventive maintenance on the belt tension, perhaps, to fix that. Same idea of friction causing heat can be applied to other use cases too. This can be used to track, let's say, a defective bearing that needs a replacement, or motor that is causing, if you have a threshold of operation for the motor and it is exceeding that, it may be an indication that some maintenance might be required there. Again, all of this would be possible only because we're able to do that continuous monitoring, and you're able to deploy a solution that can cover a large area such as a distribution facility. Now, the same platform solution that was built for ICI using this thermal imaging and Amazon's Kinesis video streams, in fact, they were able to utilize something called a Kinesis video streams for WebRTC, which was a fairly new service at the time we were building this prototype, to accomplish their business goals, which was reduce that cost by almost 33%, and also reduce the real-time latency, which I mentioned was around 6 to 9 seconds to under 3 seconds. So they can accomplish real-time monitoring as well. So the customer is now actually an active partner with AWS and is demonstrating the solution, so they can jointly present solutions such as this to our other customers as well. One anecdote I like to share is, as you saw earlier, we have a lot of automotive customers interested in seeing the automotive demos that we have here. One such customer was interested in this particular demo, even though the demo itself is not in the automotive use case, identified that you can actually use the same technology and platform to apply it to their use case, which was how to monitor EV batteries for early fire detection, long before you have a thermal runaway and have to deploy a fire suppression system that could lead to a lot of loss in terms of inventory. So the infrared cameras can again monitor that larger area, detect temperature changes long before they manifest themselves or are able to be detected by your external fire suppression systems, and that you will have the opportunity to isolate that, maybe deploy a fire suppression system early if needed, and prevent those kind of thermal runaway conditions. So we love these kind of demos and technologies that cuts across multiple domains, and have customers come in and envision how the technology can enable and solve business challenges in their industry or vertical as well. With that, we come to a conclusion of this tour. Hope you enjoyed and learned from looking at all the demos, demonstrators, and the sparks and innovation and an idea for how you can solve your problems using AWS as your partner. We'd love to host you one of these days as a customer to co-develop one of these innovative prototypes, and maybe one of these demonstrators will be featured in one of these labs or one of our tech conferences as well. So I highly encourage you to reach out to your account team and ask about prototyping and how you can come build with us.